Well, hello everybody. In this screencast, we get to deal with the same idea from the last screencast, areas between two curves. But in this case, they're going to be harder, and they're going to be harder for a couple of reasons. One of which will be that we're going to do some that involve u-substitution, and the other is going to be that we're going to take a look at areas from the sideways point of view instead of the up and down point of view. That's where we're going in the next 15 minutes approximately. So let's take a look at a picture. Let's pretend, just for argument's sake, that I'm looking for the area between cosine x and cosine 2x. Let's pretend that I'm looking for this area in here. The area oh man, it's going to bother me so much. The area between cosine x and cosine 2x from here to there. Now, you and I are both positive that when we find this area, it's going to be an integral, and it's going to be an integral of the function that's on top minus the function that's on bottom from probably 0 to somewhere. So somewhere out there, I got to figure out where question mark is. I've got to know where cosine x is equal to cosine 2x, which means I got to know where cosine x is 2 cosine squared x minus 1, and I do some solving, and I end up with 2 pi over 3. And I'll let you figure the trig out because you're probably better at the trig than I am. So this can be broken up into two different integrals if we choose. This would be the integral from 0 to 2 pi over 3 of cosine x dx, and this would be the integral from 0 to 2 pi over 3 of cosine 2x dx. And the reason I want to break it up, even though I don't have to, I mean, I could do the integration piecemeal in my head and be okay with that, but I want to show it because this one is the easier one by far, because the antiderivative is obvious. I mean, it's obvious. So, I mean, I'm feeling really good about that. And in fact, sine of 2 pi over 3, oh mercy, that's root 3 over 2, minus sine of 0, that's beautiful. That is just beautiful. This piece. This is not cosine x, this is cosine of 2x, so you almost want to do this with u-substitution. In this, u would probably be 2x. I don't want to be 2x, doesn't matter. And du would probably be 2 dx. We don't have a 2, so we compensate. And so what have we got? We've got 1/2 the integral of cosine of u. Well, cosine of u, the antiderivative of cosine of u is sine of u from, these are x limits, so I suppose we can use x limits. So now minus 1/2 of sine of 2 times 2 pi over 3. Oh my goodness. Sine of 4 pi over 3. Sine of 4 pi over 3, that's third quadrant. That's a negative number. That's negative root 3 over 2. Sine of 0 is still 0. So what have we got? We've got radical 3 over 2 plus radical 3 over 4, and that turns out to be 3 radical 3 over 4. How could we check ourselves to make sure we're right? We could use our calculator, run an f and int, a function integration on this thing, and make sure that the decimal equivalent we got for that is the decimal equivalent of 3 root 3 over 4. Okay? Okay. Consider the picture. Consider that we're going to try to find the area between two curves. One curve is a nice radical function. One curve is a nice parabolic function. One might argue that those are the same kinds of function, but we won't do that here. looking for the area between two curves, which means we're looking for an integral of top minus bottom from left to right. Well, a little bit of algebra here will confirm that left is 0 and right is 6. If you were to set those functions equal to each other, they cross exactly twice at x equals 0 and x equals 6. So this time I think I will do this one piece at a time. We're looking for an antiderivative. We'll sub in 6, sub in 0, and subtract the answers and hope we end up with good things. This piece is the easiest piece. We love that piece. This piece is the next most easiest piece because if u is x minus 2, then du is dx. So we almost don't have to do a formal u sub there. We're thinking in this case that this is just power's going to go up by 1, and we're going to divide by the new power. Well, if we divide by 3, this 6 becomes an 18. It's this thing that's bothersome to us. If u is 2x plus 4, then du is 2 dx. We don't have a 2 here, so we've got to compensate by throwing a 2 there, but there's a 1/2 in front of that. There's a 1/2 in front of that. What's in here is the square root of u. That's u to the 1/2. How do we take the antiderivative of u to the 1/2? Well, the power goes up by 1. That would be 3/2. And then we divide by that new power, which means we multiply by its reciprocal. So now, all we have to do is sub in 6, sub in 0, and subtract the answers. So if we substitute 6, that's 16 to the 3/2, times 1/3, that's 64 thirds, minus 4 cubed over 18, I don't know what that is, minus 4/3 of 6, minus what we get when we sub in 0. That's 4 to the 3/2 times 1/3. That's negative 2 cubed over 18. Wait. Negative 2 cubed over 18 minus 0, and arithmetic tells me this is 20 over 3. So big pieces to remember because I'm always combining ideas for us. It is possible to find the area between two curves where to do so requires us to use u-substitution. That becomes important. Here's the other thing that becomes important, and it's the other big piece that we'll talk about, and I'll have to draw this because I can't graph it on a TI because I'm not graphing functions. Let's consider this parabola. This is a sideways parabola. This is the parabola x is y squared minus 9. And let's consider this line. This line is y equals 1/3 x minus 3. And you'll notice that they cross in two places. They cross at 0, negative 3, and they cross way out here, figure not drawn to scale, at 27, 6. And what I'd like to do is I'd like to find the area between those curves. And I drew the shading in that way for a very specific reason. I would like us to consider that if we tried to do our rectangles vertically, we'd be fine here, and we'd be fine here. We'd just do top minus bottom, and we'd be fine here. We would do top minus bottom from left to right, and that's fine through here. But it's not fine here, because we're not going blue minus red anymore. We're going sort of sum of blue minus rest of blue. And so vertical slices don't do so well here. So instead, we're going to do horizontal slices. We're going to fill the region with rectangles that are all lying horizontally. Now, what does that do? Well, it still turns into an integral. We're still going to find an integral. But instead of all the widths being tiny changes in x, the widths are all tiny changes in y. And if the widths are all tiny changes in y, this has to be a dy integral. And if this is a dy integral, then the limits that I use have to be y limits. We have to go from the smallest y to the biggest y. And the functions themselves have to be in terms of y. For the parabola, this is already accomplished. For the line, this is not accomplished. So we'll just make it so. And we're going to do left minus right from bottom to top. Instead of top minus bottom from left to right, we're going to do right minus left from bottom to top. The problem is no more functionally difficult than any other area problem we've ever done. And in fact, this is actually kind of nice because we're going to get a negative y squared. We've got a plus 3y. We've got a plus 18. And we can find that antiderivative, negative 1/3 y cubed plus 3/2 y squared plus 18y, evaluated from -3 to 6. And we just sub in the numbers and go at it. So nothing fancy there. Let's see. So who wants to do arithmetic? Answer is nobody. Let's see. That's negative 216 divided by 3. That's 36 divided by 2 is 18 times 3 is 54. 18 times 6 is 108 minus whatever we get when we sub in negative 3. So negative 3, that's negative 27 over 3 over negative 3 is positive 9. Negative 3 squared is 9. This is 27/2. And then this thing right here is, oh goodness, negative 54. And so that whole thing, you punch a couple of buttons. And I think you get 243 over 2. I'm not positive about that because I did it really quick, but I think that's what you get. We could check ourselves by doing the integral on our calculator and seeing what our calculator gave us. But it seems reasonable from the picture. I mean, the picture is vastly not to scale. Okay? So, something for you to consider. You should probably know how to do this before we show up. Ooh, that is hideous. So let's see, this is the parabola. X plus 1 is y minus 1 squared. And this is the line x equals 2y. I would like to find the area in between them. Take a moment, we'll give you an answer. I hope that's what you got. I hope that's what you got. All right, friends, that is the goal for the day, figuring out how to do area problems either that use u-substitution, nasty review of last time, or area problems that use horizontal slicing to its advantage, to their advantage. All right, very well. See you when we get there.